pieces. Okay. Okay, I want you to jump ahead a little bit. We're going to come back. And I want you to look at, where does it say? The second page really quick. It's called the Fundamental Theorem of Algebra. Very fancy looking, okay? A polynomial. Okay, it's just on the second page, I think, right? Okay, so a polynomial, remember we learned that like first day of class. Poly means many, nomial means like terms. So it's like any version of these things with lots of terms being added together. Of nth degree. Anybody remember what the word degree means? Anybody remember what the word degree means? Come on, guys. The highest exponent, the biggest exponent, okay? Good. So any polynomial of nth degree has n complex. Do you remember what complex numbers are? Anybody remember what complex numbers are? Think of our big Venn diagram in Unit 2. What's a complex number? Anyone remember? You guys are breaking my heart. Some of you drew adorable cartoons about it for me. Complex numbers.
Is that the thing we did like the book for?
We did the book for it, yeah.
Wasn't it like positive?
That's a good guess. That's natural numbers.
That one? No.
Was complex the smallest circle or a biggest circle or in the middle? It's the very biggest one. Complex numbers is all numbers. Remember when we would have to go through and like define them, we'd have to put a C by absolutely everything, right? Because complex numbers is any type of number. Irrational, rational, imaginary, real. Okay? So, and then solutions means like answers. So it says a polynomial of nth degree has n complex solutions. Okay, so everything we've dealt with in this unit is what degree? You guys remember? Or you can look at this page. Everything we've dealt with in this unit is what degree? Degree, highest exponent. So you can look at the examples on the last page or this page. It's 2. They're all quadratics, right? Good? So how many answers should every problem have? 2. So what is the degree of each equation below? 2. So how many answers should it have? 2. That's the fundamental theorem of algebra. If we had a cubic, it'd have 3 answers. If we have a linear, it has 1 answer. What we're dealing with this whole unit is quadratics. So each one should have 2 answers. So that's a good way to check your work, right? Every problem we do should have 2 answers. Does that make sense? Okay. So now tell me again, if we look at the first one we did, how does that relate to what we've already done with solving? How does what we just talked about relate to what we just did with solving at the front of this page? Yeah, Cheyenne?
Because like this, the highest exponent number, like the highest degree matches the amount of answers.
You got it. If I didn't remember to do my positive and negative, then that squared would have only had 1 answer, and I have to have 2 by the fundamental theorem of algebra. So that's even another reason why we need the plus or minus. Good, Cheyenne. Does that make sense, you guys? You with me? Okay, so let's go ahead and look at 2a. Can I square root both sides right now? Okay, one thing to remember, and maybe this will help, when you're solving things, is when normally I'm working on things, I do PEMDAS, right? When I'm solving things, when you're undoing things, you have to kind of do backwards of PEMDAS. So like, do you see how normally exponents is before multiplication, right? But if I'm undoing it, I gotta go backwards. So I need to undo the multiplication first, okay? So with that in mind, what should I do first on 2A?
Divide by 5.
Good. And if I do it to one side of an equation, I have to do it to the other, right? So x squared equals what? $25, good. Is x alone? I did my attendance backwards. I marked all of you guys absent and all the absent people here. Good thing I realized that before you all got emails. Your advocate calls you down and, yeah, oops. Typical Summers. What do I need to do to get the x alone? Anyone? Anyone? Good. Square root. So x is 5 and -5. Look at this. You guys are doing awesome. Another one? B? What should I do? Square root. Oh, the whole point of square rooting is to get rid of that squared. I can try typing it in if I don't know for sure it's a perfect square, or you can use that times table that I make for you guys, right? The diagonal line shows the perfect squares, right? This one's not, which means I know I need to do a factor tree. Man, Summers, you always make us use things from previous units in the next unit. Well, we'll be doing factor trees all year. You're welcome. So x is 2 square root 3 and -2 square root 3. Am I ready to square root on C? No? Masa says no. What do I need to do first? Good. Am I done? Is x alone? Do I have 2 answers? No? What do I do? I gotta what? What?
I forgot what it's called. It's the thing. Square root.
There it is. What's the square root of -1? Oh, that's right. It's I. I and then -I. Man, you guys are smarter than your calculators. What? Big idea of solving using square roots. Undo stuff around x by SADMEP. What the heck is SADMEP? Oh, backwards PEMDAS. My bad. Thought I'd get a laugh or two out of that. No, thanks, guys. And then always positive and negative solution to the square root. We always plus and minus our answer from the square root, because 2 positives stay positive and 2 negatives stay positive. Okay, this just kind of explains what I was saying with the fundamental theorem. If I were to solve for, oh, hold on, let's